Hi everyone. So today we're going to work on what is called the fundamental theorem of algebra. It's kind of like why we're able to do what we've been doing, and some of this stuff you probably already summarized or kind of thought about, but now we actually are going to have a theorem, which means somebody proved this somewhere along the lines and that it works for anything. So we're going to look at two of them and then we're going to put some stuff together. All right, so our first one is called the conjugate theorem. And basically says is if we have a polynomial with rational coefficients. Now keep in mind that just means that the numbers in front of our variables are integers. They can be fractions and decimals, but we usually don't write it that way. Then the irrational roots of p of x equaling 0 occur in conjugate pairs. That is, if a plus the square root of b is irrational root of a, with a and b being rational, then a minus the square root of b is also a root. Give us a minute, we'll explain what that means. It also says that if it has real coefficients, then the complex roots occurring in conjugate pairs. That means if a plus bi is a complex root, then a minus bi is also a complex root. So what exactly does that mean? That basically means that square roots and i's come in pairs. So if you know one, you know another. For example, if I said the square root of 6 is a root, then you have to say that negative square root of 6 is a root. Or another example might be 6i is a root, then negative 6i is a root. So i's always come in pairs and square roots always come in pairs. So if you know one, you know another. Okay, so let's take a look at a couple of examples. It says a quartic, meaning to the fourth power, has rational coefficients. It says if square root of 2 and 1 plus I are roots, what are the other two roots? Well, we just said that square roots come in pairs. So if square root of 2 is a root, then you also have negative square root of 2. There you go. Excuse me. It also says 1 plus I is a root. So if 1 plus I is a root, then 1 minus I is also a root. So remember, quartic means there had to be so we have 4 roots here. Okay, so that's pretty good. All right, so what does that mean? That means if I know the roots, I can create or develop the polynomial. What is the third degree polynomial function y equals p of x with rational coefficients so that p of x is equal to 0, has roots of 4 and 2i. So that means that negative 4 is a root, 2i is a root, and negative 2i is a root. Now we're going to build the polynomial, which means we're using the x minus a kind of form, and a is our roots. Okay, so we're going to have x plus 4, because remember when we put it in, it's going to change the sign, x minus 2i, and x plus 2i. Okay, and again, the conjugate theorem says that if one I is a root, the other I is also a root. Okay, so I'm going to multiply the i's together. I'm going to find that a little bit easier. Okay, so if you notice, the two ix's are going to cancel each other out, and you're left with x squared. And you also have to remember that I squared, remember that's equal to negative 1. So we have negative 4 times negative 1, that makes it plus 4. And we're going to multiply that answer by x plus 4. Okay, and put it in order so it's all nice and neat here. And there's your polynomial of degree 3 that has integer coefficients and has roots of negative 4, 2i, and negative 2i. All right, let's try the big one. This is a pretty important theorem. The fundamental theorem of algebra says if p of x is a polynomial with degree greater than 1, so in other words, it has to be squared, cubed, fourth, so on, then p of x equals 0. Meaning that I'm going to solve it, has 3 things. exactly n roots, including multiple and complex. Why is that important? Well, it says that the degree is n, and it tells us that it has n many number of roots. So our exponent, our degree, tells us how many roots we have. It has n number of linear factors, meaning if we have n number of roots, then we have n number of factors. And at least one complex zero. That means that it could be in the real number system / complex. Meaning if 4 is a root, then 4 plus 0i would be the complex root. But there's always a root. There's at least one root for every single polynomial. Okay? All right. So let's put this all together now. Everything that we move. Well, we're not going to talk about end behavior yet. We're going to put all that together in a little bit. All right. So what are the roots of all the roots of x to the 5th minus x to the 4th minus 3x cubed plus 3x squared minus 4x plus 4? All right, so let's do a lot of stuff here. We want the total number of roots. Okay. All right, so according to the fundamental theorem, our highest degree is the number of roots. So this guy has 5 roots. Does that mean he crosses the x-axis 5 times? Maybe. He may have a whole bunch of imaginary guys too. Let's take a look. All right, so now we're going to talk about possible or positive reals. So we're going to use Descartes here. Okay, remember that Descartes said that the number of sign changes is going to tell you the number of positive real roots. So let's count. 1, 2, 3, 4. So that means there are 4 places that it crosses the x-axis on the positive side. But remember, Descartes also said that you have to decrease by an even number, which means that we have to decrease by 2 each time. So there could be 4, there could be 2, or there could be 0. Negative real roots. Okay, so remember, negative real roots means that I'm going to put in a negative x everywhere I see an x and clean it up. Okay, so remember that an odd exponent is going to cause the answer to be negative. Let's count the number of sign changes. 1. Just 1. So this is going to guarantee me that it's going to cross the x-axis on the negative side 1 time. That's it. It has to. It has to cross on the x-axis on the negative side. So when I'm looking for my roots, I'm probably going to start in the negative side because I know I guaranteed have to have one. Okay. Complex or imaginary? Let's call this imaginary. Now this is where people get a little confused. Okay, so when I come up here, see it says 2 or 0. All right. Let's put this all together. And so we know that the total number of roots is 5. So if you follow along here, 1 plus 4 gives me 5, which means there would be 0, let's give this a color, imaginary roots, because we'd have 4 and 1. Now, if we only have 1 negative and 2 positives, but I'm supposed to have a total of 5, and now I only have 3, that means there has to be 2 imaginaries. And then we keep going. 1 plus 0 is just 1, which means there had to be 4 imaginaries. Okay? So it depends on the combination. All right, let me make this a little smaller so we have more room to work. Okay? All right, let's talk our P and Q. P, remember, is the factors of the last. So our factors are 4. So 1 and 4, -1, -4, -2 and -2, and +2 and +2. Okay. All right, and then factors of 1, that is our cube. So that's +1 and -1. So P over Q would be ±1, ±4, ±2. Okay. All right. So again, we're going to use our calculator to help us with make our lives so much easier. So we're going to put our equation into y equals. Okay, I see 3 places where it crosses the axis. Here, here, and here. Okay, so I see 2, 1, and -2. All right, so that at least gives me 3 out of my 5 zeros, and we still need to find the other 2. All right, so here's what we're going to do. I'll move that a little bit out of the way. Okay, so I'm going to start with putting 2 on the shelf. Okay. Now remember, every time we do this, we are decreasing our exponent by 1, so because we're dividing by x to the first. So we're decreasing by 1. So when my result is going to be an x to the 4th problem. And if you don't get 0 when you do this, and we found that 2 is crosses the x-axis, then you did that math somewhere along the lines. Now I'm going to put -2 on the shelf because that was also a solution. Place where the graph crosses the axis. Okay, notice I had a 5th. Now, the first time I did it, it's down to the 4th. Now this is a cube. Okay, and I believe the other one was 1. Now I'm down to an x squared. Okay, so these 3 are roots, -2, 2, and 1, but now I have to find x squared plus 1. I'm just going to set that equal to 0 and make this x squared equals -1, x equals plus or minus the square root of -1, so x is equal to plus or minus I. All right, so our final answer here is like, what are all the roots? Our roots, our solutions are 2, -2, 1, I, and -I. Okay, you want to try another one together? That's a lot of information, so let's try another one. Okay, notice that the first thing I noticed is that A, it's not equal to 0, so let's do that. Make sure it's in order. And then I also noticed that it's, I have a GCF. So I'm going to take that out. Because again, I'm trying to find the roots. And let's make our lives easier. Okay, so we already know that x equals 0 is a root. So let's eliminate him from the picture here, because now I got to find the roots of x cubed plus 2x squared minus 13x plus 10. Okay, so I'm going to go through the process. All right, Okay, so total roots is 4, but we already found one. Okay, so we have positive real roots. Okay, sign changes 1. Oh, 2. All right. Yeah, 2 and then decrease by 0. Okay, negative real roots. Okay, I'm going to change all my signs. I'm going to work from the x cubed one. All right, looks like there's only one sign change. Okay, now we already know 0, so that's one of the roots. So 1 plus 1 is 2, plus 2 more gives me 4. Okay, so complex or imaginary is going to be 2 or 0. Okay? All right, so let's do our P over Q. And again, we already know that 0 is a root, so I'm going to use the x cubed one. So factors of 10. So that's 1 and 10, negative 1, negative 10, negative 2, negative 5, positive 2, positive 5. Q in this case is 1. So we have 1 and negative 1. So P over Q, plus or minus 1, plus or minus 10, plus or minus 2, plus or minus 5. Okay, let's put this in. All right, I'm going to use the one that before I factored it out. Oh. That's 13. I knew something was wrong. Okay. All right, so you see that 0 is a root. There it is. Okay, and it looks like 1 and 2, which are both on our list, are factors. Okay, so. All right, now since I already know 0 is a root, put 1 on the shelf. Now, since I'm using the x cubed one, then what's the result is going to be an x squared. Okay, so our answers are 5, negative 5, 2, and up here is 1, and then we had 0. Okay, so those are all our roots. All right, why don't you guys try the next one on your own, pause the video, work it through, follow like all the different steps, see if you guys get the right answer. All right, let's see how it goes. All right, so we had total number of roots is 4, positive, there was only one sign change. Negative real roots, there were 3, decreased by 2, or 1. And complex or imaginaries were 2 or 0. So I listed all my P's, I listed all the Q's. So you have plus or minus 1, plus or minus 18, plus or minus 2, 9, 3, and 6. So when I graphed it, it crossed at negative 3 and 3. So I put them on the shelf. Okay, then I got all the way down, I got x squared plus x plus 2. Have to do quadratic formula here, it doesn't factor. So you have negative 1 plus or minus I squared root of 7 all over 2. So our 4 total roots, we have 2 reals and 2 in the imaginaries. All right. Let me know if you have any questions, guys. Stay safe out there, and I'll talk to you again real soon.